Ms. NurishSyafiqa and my metric number is A23CS03016. For my secure programming alternative assessment, I analyzed the MediChain API security branch. As you can see, this is the search, not the vulnerable.php, which is the original code one. As you can see, the critical vulnerability in SQL injection. The code concatenates user input directly into the SQL query using the SQL select where name like keywords, and this will be allow the attackers to inject the malicious SQL commands. So my refactoring use for the search.php is I use the PDO prepare statements with name placeholder like a keyword. The database engine compiles the SQL structure separately from the data and making the SQL injection impossible. For the authentication vulnerable in PHP, which is the original code one, as you can see, the code uses the strlen, which counts the byte, not the character. In UTF-8, multi-byte characters can bypass the boundary check. I replace it with the MB*len, which counts the actual character, as you can see. So the authentication also use the MD5 hashing, which is fast and unsalted, and also can be enabling the brute force attacks. And I upgraded to Argon2 ID, which is the memory hard and includes the built-in salting. So in the crypto.php, which is the original code one, the original code used the AES128 ECB mode with a hard-coded key. ECB mode encrypts each 16 bytes block independently, so identical plaintext blocks can produce the identical ciphertext blocks and leaking the pattern in the data. So for my refactoring use as the AES256 GCM that can be authenticate the encryption with a 12-byte random IV generate by random bytes 12. This can be ensure the identical plaintext block produce the different ciphertext blocks. And for the serialization sequence, I pack the IV 12 bytes, the ciphertext, and the 16 bytes authentication tag into a single structure. Then base64 encode it for a JSON transport. So during the decryption, I extract the IV tag and ciphertext separately. So the OpenSSL decrypt function automatically verifies the authentication tag. And if the data has been tampered with, the function will be tampered with the function return false and also preventing the decryption. As you can see, this is a crypto test.php, which is the PHP unit test suite. So you can see all the code that I refactorize the version. So now I'm going to live my terminal demonstration. First, I run my encryption test, which is PHP test crypto.php. So as you can see, the IV generate. As you can see, the IV generate the encryption success. succeeds and the authentication tag is created. The decryption also restores the original plain text. You can see this here. So when I flip one byte of the ciphertext, the eight authentication false and return false. Authentication fails and return false, and proving the system can be detect the tampering. So now I'm going to run my automate test suite with my PHP unit. So as you can see, the output shows OK, 3 tests, 5 executions, which is all green, meaning all the test is passed. So this gonna prove that my refactoring successfully disrupt the exploit chain. So that's all from me. Thank you.